Hey guys, this is EdRoh. Today we're going to be checking out several NFT contracts that all make the same one-line mistake in their contract that lead them to lose out on hundreds of thousands of dollars, as well as thousands for the consumer. So how does this exactly happen? Nowadays, when you mint NFTs for a contract, there is typically a limit to the number of NFTs you can mint per wallet. This is especially important for whitelist or pre-sale mints, where only specific privileged wallets should be able to mint a limited number of NFTs before the public sale. However, because of the code I'll mention shortly, some people were able to mint an unlimited amount. So what they would do is start minting, then selling, and then minting and selling repeatedly until the price of the NFT went to zero. This is highly undesirable. Because of this, people lose faith in that NFT collection, or rather the appropriate term in this space called fudding the NFT, because of the obvious flaw in the contract. In the crypto space, the slightest indication of FUD will cause people to sell faster than the American government can tax crypto. What is this line of code that is causing this problem? So this right here is a single line of code that is costing NFT creators and buyers thousands of dollars. Now, this is a simple require statement in Solidity, which is simply a check statement that is supposed to prevent bad things from happening. At first glance, it seems okay because what you're doing is you're checking the balance of the person who's minting, which is message.sender, and making sure that it's less than max per wallet. If that's true, you're going to continue minting and you can continue running that function to mint your tokens. If it's not true, you're going to get an error that says exceeds max per wallet. So if you think, let's say for example, if someone holds 2 NFTs and the max per wallet is set to 2, that person cannot hold any more NFTs. So you would expect this to be okay. Well, there's a problem with this logic, however, because what this person can do is, let's say Jack mints 2 NFT tokens. What he can do is he can either sell these NFTs to someone else, or he can transfer the NFTs to another wallet, which means that their balance of NFTs will be 0 again in Jack's main wallet. And because of this, he is able to mint 2 more because all we're doing is checking by the balance. So Jack can mint another 2 NFTs, sell those 2 NFTs or transfer those NFTs, and he can continue doing this process an unlimited amount. So you would think a common problem like this would be accounted for by many developers who are creating these NFTs, but they're actually very common. And I've seen this happen in multiple hyped up NFTs, and the price just tanked when people were able to exploit this problem. So one example is Pixel Mythics. So this one was pretty recent. This was also hyped up, but people found out that you can continue minting, selling, and the price would drop, and as you can see, it's 0.045. What they eventually did, they redeployed the contract because of this exploit, and they created a new collection. They did mint out, but it really ruined the potential of what it could have been. So if you take a look at the contract, you can see here in the mint whitelist, you have a situation where you're checking the balance of the person who's minting, and you're using that as a required statement to check if they have minted already or not. So what a person can do is basically, as I mentioned before, they can mint the token, sell it, mint the token again. Another collection that happened, that this happened to, was CyberDodge. This is also somewhat hyped, and for sure I would think that this would mint out, but because of that problem, people stopped minting this, and this one did not mint out because of this problem. And right here, it's written a little bit differently. You can see that they have an IERC 721 contract address. This is just another way, but we're basically calling the balance of the person who's minting it and checking if it's less than the max whitelist mint. Now, again, this is another problem. So people exploited this. People did not want to touch this collection after finding that out. So this one did not mint out. Another one, Divine Wolves, this was also very hyped. I believe this one, if you take a look, this one had a different exploit. But they still had the same problem in the public one, which is unexpected. Where if you take a look here, owner token count, which is the balance of, and the mint amount, and if that's less than the max mint amount, you can't mint more. So they expected that for the public people that you cannot mint more than your max amount. So that was one exploit. Another exploit was a different one. This is not related to what we were talking about, but it was a different type of hack. But we'll cover that in another video. And then finally, there's this one, DigiDragons. This one was really hyped. But again, this one we can't see the contract because they have not published it, but they had the same exploit and people were exploiting the same problem. So now that you know what the problem is, how do we fix this? How do we make sure that people don't do this exploit? So instead of adding a check to see the balance of tokens, you can actually create a wallet mint mapping variable. You can call this whatever you want, but this will keep track of how many each wallet has minted. Once you have done that, you can go to your mint function and now we can add a require statement. But this require statement will be a little different. So what we're going to do is we're going to make sure the wallet mints of the address of whoever's minting that token plus the quantity that they want to mint is less than the max per wallet. So as long as that's true, we can proceed and mint our tokens. And if it is not true, we're going to have the normal error exceeds max per wallet. And what you're going to do after that is you're going to add the number of quantity that the person has minted or wanted to mint, and you want to keep track of it in that variable. So this keeps track of how many they have minted. This prevents them to mint more than the max per wallet. So now this is a very common solution and a common problem. It does cost a little bit more gas when you deploy the contract and when you mint the contract, or when you mint the tokens for the user, but it's not a significant amount to not go this route. You definitely don't want to go the route of balance of. This prevents people from minting inappropriately. And that's it. It's a very simple fix to a very common problem, but what people I've seen are doing, they're probably just copying from either another contract or they're seeing from some YouTube tutorials I've seen where they are copying the same line of code which involves the balance. And this is surprising to me that this continually happens. And this is this needs to be fixed. I need to see people not perform this mistake. So anyways, there you have it. This is a very surprisingly common one line of code that can cost you a lot of money when you're creating your NFT. And if you're a buyer of that NFT, you want to be very careful of things like this. Anyways, like, comment, subscribe if you like this video. I'll see you in the next one.